So what we're going to be looking at now is we're going to be looking at solving exponential and logarithmic functions. So if how we've been doing solving these before is that we haven't been really solving for x. We've been simplifying, expanding, changing different things, but we haven't been solving for like an x in the variable. Okay, and so that's what we're going to be doing now. What you're going to be doing is that if you have like 3 to the x is equal to 4, okay, you're going to take the log of both sides. Now when you take the log of both sides, you end up with log base 10. That's our basic one that we always keep. So log base 10 of 3 to the x is equal to log base 4. Based on our properties previously, we can take that x and drop it out front. That's our little power rule. So now we have x log 3 is equal to log 4, and now we want to get x by itself, so we would divide both sides by log 3, giving us x is equal to log 4 all over log 3, which is 1.2614, or 19. And to check to see if that works, you would go 3 to that power, 3 to the 2.619, and you would see you would get fairly close to 4, if not exactly 4. And so that's how you would do it. So when you want to drop a power, drop a variable from an exponent, you take the log of both sides. Okay. Now let's look at this one. So this first one, we want to solve for x. So we would take the log of both sides. When we take the log of both sides, the 2x drop out front, giving us 2x log 6 is equal to log 21. Now we would divide both sides by 2 log 6, 2 log 6, or we would divide both sides by log 6 and then divide by 2. And that gives us our x is equal to log 21 all over 2 log 6, which is approximately that decimal. Okay, and you would use your calculator to solve this. There's no way that I would have you, solve these without it. So you will have your calculator. So now the next one, you're going to take the log of both sides. So you're going to take the log of both sides. You're going to drop x plus 4. So we're going to have parenthesis x plus 4 log of 3 is equal to the log of 101. Divide both sides by log 3, giving us an x plus 4 is equal to log 101 all over log of 3. And now we would subtract 4. So we would have x is equal to log 101 all over log 3 minus 4. And that gets us approximately 0.2009. Okay. Right. So now let's do this last one. First thing we do is take the log of both sides. Take the log of both sides and drop the powers. That gives us an x log 5 is equal to x minus 2 log 7. Okay. Now when we're solving this, what we would do is that we would distribute this to both parts, okay, giving us an x log 5 equals x log 7 minus 2 log 7. And so what we would do then is we would move this to the other side, giving us an x log 5 minus x log 7 is equal to a negative 2 log 7. And from there, we would take an x out, giving us an x parenthesis log 5 minus log 7. And that equals the same thing from above. Divide both sides. Divide both sides by log 5 over log 7, getting us our x is equal to -2 log 7 all over log 5 minus log 7. Now the change base formula, what the change base formula does is that if we have a log that's not in our base 10 that we're used to, we can change something into that base 10 or any base we want it to be. And so we've got log base 4 of 45. If we want to change the base, what we're going to do is we're going to take log 45 all over log of the base, okay, which gets us about 2.7459. Okay, which means if we take 4 to that power, that equals 45. Okay. Remember with our logarithms, log of ABC is the same as saying AC is equal to B. Okay. And so that's what we're doing here. So we're going to be doing things where we have a different base than what we have originally. So we take the log. If we have the log base of something, m is equal to change the base, it would be log m all over log b. So this first one, we would go log 81 all over log 7, and then we would solve it, which comes up with about 2 point something. So 7 to the 2.2583 gets you about 81. The next one would be log 145 divided by the log of 3. And that gets us our answers of about 4.53. So if you took 3 to the 4.53, you would get approximately 145 as your answer. So that's the change base. Okay, so now let's say we have this that we want to solve. So we've got multiple logs and we want to find an x that's attached to one of the logs. First thing we want to do is combine all the logs together out of the same base so that we have it all under one nice number. So here, since it's a subtraction, that's the same as a division, so it'd be 6 over 3x. Reduce that fraction, log of 2 over x is equal to -2. Now what we're going to do is that we're going to take both sides to whatever the base is. The base here is 10, so we're going to take both sides to go 10 to the power of the number. So 10 to the log of 2 over 5 is equal to 10 to the -2. Now this becomes just the power out front, and that's why we do this. Whenever we take 10 to the log of something, whatever that number is we're taking the log of becomes the actual number. So we have 2 over x is equal to x -2, and then from here you just multiply both sides by x to get rid of it on one side, and then you would divide by x to the -2, solving through algebraically, and you'll get your answer as 200. So log 6 minus log 3 times x is equal to -2 when x is 200. So it's just solving. So if we were to solve these, we get our first one. Since we're adding, we would multiply these, so we would have log of 2x squared is equal to 11. Take both sides to the 10, so it's 10 is 10 to the power 10 to the power. And then we would drop this out front, giving us a 2x squared is equal to 10 to the 11th power. Divide both sides by 2, and then take the square root. And that gives us our answer of about 10 or 100,000 square root 5, approximately. Now this next one, we are subtracting, which means when we combine it, we'll have log of 5 over 2x is equal to 1. Both sides, 10. So we would have 5 over 2x is equal to 10. 10 to the first is 10. Multiply both sides by 2x. That would get you a 20x is equal to 5. So that means x is equal to 5 over 20, which is about 1/4 or a quarter. Okay. All right. So the first two you want to solve. So this one you're going to have to take the log of both sides for the first one, and this one you're going to have to take both. You're going to have to combine and then use your 10 power for the second one. Solve for x for both of those. And then this one, use the change base formula. Remember, log m over log b. and that gives you your number. Okay? All right. Solving exponential and logarithmic functions.